Welcome to the first task video for the week where we go and try and help you through the task. Okay, question number 1, what's corrosion? Hopefully you got the idea that corrosion is a metal reacting with air. There's a little bit more we explained in class. We don't just need air, we also need water. So it needs to be wet, or there needs to be moisture in the air. Okay, next question. Whoops, I'm clicking on the wrong thing, my apologies. Let's go down here. The likelihood of corrosion. You've got to do some research here and look up things. So we know that iron rusts. So iron rusts fairly easily. And if you go and look up gold, you'll find that gold doesn't react with any substance, doesn't react. It's found as the element. When it's found as the element. So gold's one end of the scale, iron might be at the other end. You've got to go and have a look at the other ones yourself. So it's found as, turns out to an S for as, found as the element. Okay, that is it for achieving a C level or a core level this week. You've got one more question to answer, which hopefully should be fairly obvious to you, and then you've achieved, in terms of the theory, what we're expecting at the core level. Going further, talks about the electrochemical potential. The way the electrochemical potential works is it gives an idea of how how metals want to get rid of their electrons. Now we know that all metals do get rid of their electrons when they form compounds, because that's what metals do. So all metals will actually get rid of their electrons. But there's a kind of order to it. So, for example, one of the metals that really desperately wants to get rid of its electrons is lithium. And lithium is at one end of our scale. And if you go and look it up using the website reference that we've included here, so using this website reference, if you go and look it up, lithium, you'll find is negative 3.03 volts, which tells you that the negative means lithium really wants to get rid of its electrons. If we go further down, we'll see that at the very bottom we've got gold, which is plus 1.5 volts, and above it silver, which is plus 0.8 volts. 80 volts. So compared with lithium, silver isn't as fussed about giving its electron away. The one that sits at the zero end of the scale, there had to be a zero, and scientists have chosen hydrogen to be on zero on the scale. They could have picked any element to be the zero, but they picked hydrogen. So what this is saying is that silver is less likely to want to get rid of its electrons as hydrogen, whereas lithium desperately wants to get rid of its electrons. If you look at one of these equations, the equations are actually written the other way around. The equations actually tell you how much you need in order to persuade the metal to get back its electron, which is why when a metal wants to get rid of its electron, it's a negative number, and when it's down here and you're looking at silver that's weaker than hydrogen, it becomes a positive number, because it's easier to persuade silver to take back the electron even though it doesn't want to than it is to persuade hydrogen to do that. But the basic idea is that every metal has a kind of a voltage with it. Let's go up. When we're making an electrolyte, if we looked at, say, copper, and pop that in our table, which is plus 0.34 volts. And we looked at zinc, which if we look at our table, when you've filled it out, and you'll have to fill out all these yourself, is 0.76 volts. We can see here that when we're making a battery between the copper down there and the zinc up there, there's going to be a difference in voltage. There's going to be a 0.76 volt difference to get to 0, and then 3.4 volts overall. So all up, I've got my 0.34, and I'm taking off it my negative 0.76. We'll start to see here how that's going to be equal to, I'm going to do this calculation in my head, and I should get 1.1 volts. In a similar way, you should be able to work out what other electrodes are going to do, and you should be able to work out what the maximum possible electrode is going to do. So you need to think about what metal has the most positive electrochemical voltage and what metal has the most negative one to help you work out that question. Okay, we'll now go on to the next page. Question number 6 is fairly straightforward. Just read the question and see whether you can work it out. Question number 7, say when I'm looking at this part over here, what you might like to think about is the size of the atom. So for instance, cesium, which is right down the bottom of group 1, would have a very big atom. So the outer electron is miles away from the nucleus, so it's probably not held as tightly as, say, in lithium, and therefore can be more easily gotten rid of, even though both of those metals want to get rid of their electrons. That might help you work out that question. Question number 8 is the accomplished level question. I'm not going to give you any help at all on it. See how you go with that yourself. Now we go to the experiment, and in the experiment, fairly straightforward, that we're going to put a series of metals in a series of different solutions. It might actually be easier not to follow the instructions directly and to start putting the same solution, say for instance copper sulfate, so I pick that one, put the same solution, put them in 1, 2, 3, 4, 5 test tubes, and then pop the metal in and see what happens. And you'll find, for instance, and you saw this when I did it in front of the whole class, you'll find, for instance, that the iron will go into solution and the copper will be precipitated out. So for this one, you'll actually find that you get a copper precipitate. So you get a copper precipitate. Whereas for other ones, for instance, the copper and the magnesium, you may find that the copper will be totally unchanged. So here, there's no way that the magnesium will precipitate out, so you'll be writing no reaction down there. So all you've got to do is really to have a look, see what happens, and complete the table, and then you can refer back to the electrochemical series to find out whether the metals behaved as you expected to answer the discussion questions, and finally to answer the conclusion. Okay, that concludes the first task video for today.